Morning student. In the last video we talked about the Gauss theorem or the derivation of Gauss theorem for the uniform and non-uniform surfaces. We have got the same result. Now this time we are ready to apply the Gauss theorem regarding different situation, or you can say that the application of Gauss theorem. Now today we are going to derive the Coulomb's law with the help of Gauss theorem. So let us start. Look at here. There is a spherical surface and O be the point where we have already kept the charge plus Q. Let us consider any arbitrary point on the surface of this sphere . That is ds vector, and E be the intensity of electric field at that point. So for the simplicity we have taken the spherically symmetric surface. We can take another surface, but for the simplicity purpose we have already taken that. Now look at here. At this situation I am getting that the area vector at that point and the field direction will be around the same direction. So we can say that from the Gauss law, the flux passing through this entire surface, or the total flux, will be given as phi E is equal to E dot ds for the closed curve, and that is numerically equal to the Q upon epsilon naught. Here one thing is very clear. There is only one charge that is to be played inside the region. Here E vector and ds vectors are in the same direction, so the angle between them is 0. Therefore the flux will be given as EDS for the closed curves, which is equal to Q upon epsilon naught. Or we can say that since E is uniform for any point present on the surface, so that is to be taken out from the sign of integration, and our expression becomes like this: phi is equal to E outside the integration and ds is inside it, is equal to Q by epsilon naught. Now the value of ds is equal to the surface area of sphere, which is numerically equal to the 4 pi r square. So by putting the value of ds for the close, we can see that expression becomes E into 4 pi r square is equal to Q upon epsilon naught. Or we can say that E is equal to 1 upon 4 pi epsilon naught Q upon r square. We put the charge Q naught at that point where the field was E vector and so we can see that for the Coulomb's law we have a requirement of at least two charge. So the one charge is original plus Q and the second one is test charge. So we can say that we will get an arrangement like this: two charge system which are separated at a distance small r. So we can say that F is equal to Q naught 4 upon 4 pi epsilon naught to r square, which is the Coulomb's law. So in this article we observe that we have already derived the Coulomb's law by using the Gauss theorem. Now this is enough for today. In the upcoming article we will talk about more application of Gauss theorem. Till then, bye bye, take care.